Have you ever stopped to wonder how your streaming service just knows what movie you're in the mood for? Or how a company can predict what you're going to buy, sometimes even before you do? Well, it's not magic, it's a journey. It's the journey of turning this massive, chaotic flood of raw information into razor-sharp insights. So let's follow that path together.
Pretty much everything. I mean, think about it. Raw data all by itself is like a mountain of unrefined rock and dirt. Yeah, there's value in there somewhere, but the real treasure, those precious nuggets of knowledge, are buried deep inside. You can't just stumble upon them, you have to mine for them. And that, in a nutshell, is what data science is all about.
Now, this digital ore we're talking about really comes in two main flavors. On one hand, you've got your structured data. This is the nice, neat, tidy stuff. Think of a spreadsheet. It's all organized in rows and columns, super easy to search. But then you have unstructured data. And this is the wild stuff. Social media posts, emails, pictures, videos. It has no rhyme or reason, no predefined format, which makes it a whole lot harder to work with. And here's the kicker. Most of the world's data is unstructured. And that's exactly why this journey we're about to take is so incredibly important. So here's our game plan. We're going to follow this process from start to finish. First, we'll dive into the chaotic world of raw data. Then, we'll talk about how to tame that digital mess. After that, the fun begins. We go mining for hidden patterns. Then comes a super important reality check on our results, before we finally see how all of this comes together to make a real-world impact. All right, let's start at the beginning. We're standing in the middle of a massive, overwhelming flood of information. You can call it a data deluge. It's messy, it's inconsistent, it's incomplete, and it's coming at us from all directions. You know, the very first challenge isn't about finding some brilliant insight. It's just about not drowning in all the noise. So, how in the world do we bring some order to that chaos? Well, that's where the art of pre-processing comes in. This is that crucial first phase where we have to clean everything up before we can even think about analyzing it. Honestly, you could argue it's the most important step of them all, and it's where the real heavy lifting begins. Data preprocessing is really all about improving the quality of your raw materials. It's like washing all the dirt and mud off the gold ore before you try to find the gold. We're cleaning, we're combining, we're reshaping the data so that it's complete, consistent, and ready for what comes next. Because at the end of the day, you can't get quality insights from garbage data. Garbage in, garbage out, right? Now, this whole process involves a few key tasks, but we're going to focus on these three big ones. It all starts with data cleaning, which is about fixing errors and filling in the gaps. Then we've got data integration, where we merge information from a bunch of different sources. And finally, we'll touch on data reduction, which is a clever way to make enormous data sets a bit more manageable. So let's dive into the first big headache of data cleaning, missing values. This happens constantly. Maybe a sensor just glitches out, or maybe somebody just forgot to fill in a box on a form. Whatever the reason, you end up with these annoying holes in your data set, and you've got to figure out what to do about them. Okay, take a look at this. It's a perfect, simple example of the problem. We've got a customer list here, ID, name, salary, but look at that second person, Raj. The by column is just blank. That one little empty field makes that entire row a problem for any analyses we want to do. And here's one of the simplest solutions. Just get rid of the row that's causing the problem. You see, Raj's entry is gone. Now our data set is a tiny bit smaller, sure, but it's complete, it's consistent. It's a trade-off, but sometimes the cleanest, most effective option is to just remove the incomplete data. Now, after we're done cleaning, we often have to shrink our data set without losing the important stuff. This is called data reduction. I mean, imagine you have a data set with billions of data points. You can't really work with that. So we use these smart techniques to create a smaller, compressed version that's way more efficient to mine, but still gives us basically the same results. Okay, our data is now clean, it's organized, it's a manageable size. A lot of the grunt work is over. And now we get to the really exciting part, where we step into the world of machine learning. It's finally time to use some intelligent methods to extract those hidden patterns and find the gold. This is where the magic happens.
Data mining is, well, it's exactly what it sounds like. We are sifting through all of our refined data to find those precious nuggets of knowledge we were talking about. We use these incredibly powerful algorithms to spot trends, relationships, and weird anomalies that a human being could just never, ever find on their own.
So, one of the most common and powerful techniques in data mining is called classification. When you boil it all down, classification is really just about prediction. Based on all of the data we have, can we predict which group or which category something new belongs to? Is this email spam or not spam? Is this credit card transaction fraud or legit?
And trust me, you see classification at work every single day. When your inbox automatically shoves junk mail into the spam folder, that's classification. When your bank sends you a text about a weird charge on your card, that's classification. It's even being used in medicine to help analyze medical scans or to automatically tag your friends in your photos. It is everywhere.
So, we found some cool patterns, and our model is making predictions. That's awesome. But how do we actually know if it's any good? We can't just take its word for it. We have to grade as performance, which brings us to this absolutely critical step, the reality check.
This is the one question every data scientist has to answer. Are the patterns we found the real deal, or are we just seeing ghosts in the data? How well is our model actually doing its job? To figure that out, we need a way to measure success and failure. And our main tool for the job is something with a kind of funny name, a confusion matrix. Now, despite the name, its whole purpose is to make things crystal clear. It's just a simple table that gives us a complete picture of how our model is performing by showing us exactly what it got right and what it got wrong. Let's break it down real quick. A true positive is when the model correctly predicts yes. A true negative is when it correctly predicts no. Those are our wins. But then you have the errors. A false positive is when the model says yes, but the answer was actually no. And a false negative is when it says no, but it should have been yes. Laying it all out like this tells us exactly where our model is strong and where it's messing up. From that confusion matrix, we can calculate all sorts of performance scores, but the most basic one is just accuracy. It's simply the number of times we got it right, the true positives plus the true negatives, divided by the total number of guesses. It gives us a great high-level answer to the simple question, overall, how often is this thing correct? And that's a fantastic place to start. Wow, what a journey, huh? We started with a total mess of raw data, we wrangled it, cleaned it, and turned it into a refined data set. Then, we built a model and we tested it to make sure it was accurate. And now for the payoff. Let's see what happens when we unleash this power on the real world. The impact of this whole process is just staggering. It's what fuels medical systems that can analyze scans to spot diseases earlier. It's the engine behind personalized financial services that protect your money from fraud. It's how you get those movie and music recommendations. It's behind the agricultural models that help farmers predict crop yields, the logistics apps that find the fastest delivery routes, and the marketing strategies that actually understand what different groups of customers really want. So that journey from raw numbers to real-world impact is a complicated one, but it's methodical. It's this amazing process of cleaning, mining, and testing that literally turns chaos into clarity. And it really just leaves us with one final, very exciting thought. We have built this incredible engine for answering questions, so what's the next big question we should ask it to solve?